Hello and welcome to another video. Today we have an Asus ROG Strix B650-F gaming on our bench. This is not from a viewer, I actually bought this board. And it is so long ago that I don't even remember what is wrong with it. It's been sitting in my stash for quite some time. So we will have to completely figure out what is wrong with this without any backstory. Because as of a genius as I am, I didn't even write down what was wrong with it. What the listing said when I got this thing. So let's start with our usual checks of resistance first, so that this board doesn't blow up our bench and my tools. So let's see, 3 volts, 3.3 volts. That is not good. That we hate to see that. That is 4 ohms on 3.3 volts. That is awful. Okay, that's an awful start to a video. 12 volts not shorted. 5 volts not shorted. 5 volts VSB not shorted. 12 volts not shorted. 12 volts to the CPU not shorted. 3.3 volts being shorted is a very, very bad sign. You do not want to see that. Because 3.3 volts is basically only used for logic parts. And if we are not incredibly lucky and there's some random capacitor on 3.3 volts that blew up, we will have like... Okay, I will call it now, this is a dead PCH. I will just say it. Because it's probably coming anyways. But, who knows? Maybe this is my lucky day. And I got a board that does not have a dead PCH. But let's take off all of these. Let's take also the PCH heatsink off of here. Which is really not easy because it has this mechanism where it's easy to open up the latch for the PCIe. And I don't know how that removes. If that removes by itself. Oh no, okay, we are lucky. It removes just like that. Okay. The PCH doesn't look exploded. That is a good sign. But the question is it damaged? Is it shorted via the 3.3 volt line? So I cannot see any obvious charring marks as of yet for the 3.3 volts being dead anywhere. Nothing seems to be blown up. But I am very scared to inject 3.3 volts or like inject voltage into there to see what is actually getting hot. But what can you do? Let me get my thermal camera. So I have the thermal camera here and let me get a setup for the injection of voltage. So 1 volt at the tweezers. Let's see how much current draw. We have 400 milliamps. 400 milliamps. There's something there. This looks like a PCIe switch that is getting hot. PCH doesn't seem to heat up. But yeah, that seems to be like a PCIe switch that I see. I've seen this before. If one of these switches is dead, there's probably more that are dead. But most of the time they are then on the back side, but I cannot see a single one on the back side here of those switches. Those switches are most of the time very expensive because they are 5.0 switches. But this might not be that because these switches go to the PCH, not directly to the CPU. Interesting. Don't give me hope. Please. This board is going to give me some hope and then it's going to crush me. Let's see. Let's go get the macro lens in here. Why is my phone getting dim? Don't get dim, phone. Yeah, it's definitely this switch that is damaged. You can see it heating up. So this switch has to be removed. Question is, will our resistance go up if we remove that single switch? Well, there's only one way to find that out, and that is by removing it. The biggest problem with these switches is that my hot air alone does not do the job of removing them, but I will have to preheat the board at least a little bit in order to take this off. And I don't want to disassemble a lot of it, so the preheater will go under there, but it will be at very low heat, so that I mostly just get the section of this thing, and that I don't damage anything while preheating, because this preheater has a lot of strength. Like, it can actually heat up pretty well, but only a small area. So I will have to set it to like maybe 150, something like that. So, and also get only the area that I actually need hot, with as little plastic components as as I possibly can get onto there. Like that should be fine. Let's go even a little bit further like that. Let's get the battery out of here so we don't heat that up too much. And let's it now heat up. I will be adding some flux onto there. Do this one right here. And yeah, with that, let's remove this thing here, because this will smoke terribly if we heat that up too much, the M.2 pad. And there's nothing else really that we need to remove, only that there. And then we will be able to blast this thing. I made sure that the heat sinks are well off of the area that is actually getting preheated. So yeah, let's let this soak for a little bit, that there's actual temperature in this board, and then I will be trying to blast this off. About 10 minutes later, it should be hot enough now for me to take my hot air gun, take a good pair of tweezers. We need a lot of heat, so we will go for like 470 degrees, 90% airflow. And let's now try to get this thing off of here, because these are not easy to remove. I have had it before where I had to remove these. I had a board where all of them got shorted at once, and I ripped a pad removing them. I do not want that to happen again. And now it removed very easily. Thank God. That is very great. But as long as it's still on the preheater, I want to check if our short is now gone or not, because it might now reveal another one being shorted, because these very rarely come alone. Most of the time there's more than one dead. And we can see we still have 8 ohms. So this will be very hard to see with the thermal camera, because the area is very hot now. But I will be trying to see if the one next to it is also damaged. And in order to do that, I might need to increase the voltage. Before I was using a single volt, and now I might need to actually inject 3.3 volts in order to see properly if it is shorted or not. Thermal camera shows a lot of hotspots, as we can see. So let's get the setup here again. So get this post and get the tweezers to be putting into the slot again at the 3.3 volts. And now it is heating up. Okay, I cannot see anything yet. Let's increase the voltage bit by bit. We are at 2 volts now. And I still cannot decisively say that this one is the one that is shorted. Oh, now I can. Yeah, it definitely heats up. Okay. Let's go to 3 volts then. Yeah, both. This one is also shorted. Like I thought. They rarely go dead by their own. So in this case, again, we have another one of those. Good that we didn't remove the preheater. This is just experience by that if one of these switches dies, most of the time more than one dies. Or like all of them probably die. And in this case it's probably the same. But we are lucky it's not the PCIe 5.0 switches. These are the one for the lower slot. So let's remove this one as well. And let's hope that we then have kilo ohms of resistance on our 3.3 volt line. So that was again very easy to remove. The preheating makes that very good. Even though the preheater is only set to 144 degrees. For no specific reason. So let's check now the resistance again. This is going to be the crucial part now. 25 ohms. That is still not fine. If now the SIO is going to heat up, I'm going to cry. Okay, once more voltage injection. This is, like I said, this is the problem when you see a 3.3 volt short. You just don't want to see a short on 3.3 volts. It's just awful. You're just in for heaps of trouble. So I will get the thermal camera out again and I will try to find something that is now heating up, because 25 ohms is now a lot harder already to spot, especially if the board is like it is currently in a state where it's really heated up. So whatever heats up, I'm not able to see it currently with the board being as hot as it is. So I will have to remove it from the preheater. And I will have to set it to the side to cool down. And when it's cooled down, only then I will be able to spot something with the 3.3 volts being shorted. So, time to just let it cool down and wait. So, I've waited some time for this to cool down. And I had a look. And guess what happened? We will have to focus down on my phone. Get the ring light out of here so we don't have the reflection. And have a good look now. Now we need 3.3 volts, not 1 volt. 3.3 volts, and have a good look. Can you see that? Probably dead PCH. I do not know if that is normal. Like, it might be normal to have low resistance on the, like, the PCH has low resistance, don't get me wrong, but it shouldn't be directly connected to the 3.3 volts, I'm pretty sure, and then shouldn't heat up like that. So yeah, other stuff on the 3.3 volt does light up, but the PCH is just very lit. So we're going to be trying. I want to see how this board behaves when you actually try to put a CPU into there. how far this board can get, because there's no obvious short anymore except the PCH, and there's 500 milliamps of power draw on the 3.3 line, which a power supply can definitely handle, so it won't blow up the power supply instantly. Yeah, we're going to be trying that. It's probably a lost cause, and like I said from the beginning on, if you see that on 3.3 volts, you are basically screwed. Like, it is almost every time that case. That is why I've called it from the very first readout that we had of the resistance. I was thinking that this is going to be the case on here. But in a last ditch effort, let's build this board up and see how it reacts at least. Sadly, I think that this will be a 70 euro paperweight. Oh, well, paperweight. There's a lot of stuff I can harvest from here. Like, this will be a great donor board, of course, but 70 euros for a donor board like this is pretty bad, especially if you consider what I've just saw, that there's problems with the pins here also. So yeah, let me get my CPU. It might even already have problems with in standby power. In standby power, we might already see it heating up so much that we won't even be able to push the power button. But let's see now. So let's see here. Getting my adapter into here. And let's now turn on the power supply and see if the passive power consumption is already going to be very high. No, it's very low, the passive power consumption. Interesting. So let's see if we can press the power button. There's nothing happening with the press of the power button. It is like the 5 VSB isn't even connected. Oh, maybe now. Oh, we have a reaction to the power button. That is very interesting. We have CPU DRAM. Is this actually trying to post? No way. Huh? What? Is this not a dead PCH? The PCH is not getting very hot. Like, I can lay my finger on there. Let me get a display capture onto here. Let me turn this off for a second. This cannot be true. No way in hell. No way. No. This wasn't just two dead switches. No. That's not how that works. No. This is not what my experience tells me. Hold your horses. What is happening here? I do not believe that. Can this be true? Because the PCH isn't hot at all. Like, my finger barely feels any heat. 3 amps of power consumption, 4 amps. No post LEDs anymore. But the current is jumping a lot. Do we have... Let's get a keyboard into here to see if we have indication. Maybe I just don't have a capture right now. There's no keyboard indication, okay. So this board is still trying to post. But I would be pretty sure that this board is brain dead because of the dead PCH. But it's weird. It's like, no way. Nah. I think just some of the USB ports aren't working and it's just my display capture. No way. Because, have a look at this. We have indication on the keyboard. Let me restart this board if we get a capture then. And it's on again. No way. Okay, let's get a GPU into here so that I can have a display capture, because I think the display output also goes through the PCH. So if that is dead, that also won't work. So let's get a dedicated GPU into here. And let's try this again. Cannot believe what I'm seeing right now. 6 amps. Is this really trying to pause? Is this trying to give me a picture? It's probably going to gobble up some errors because of this graphics cards that a card that it doesn't like. But we have booted again. Because there's an indication on my keyboard, but I do not see anything as of a post screen yet. Can I get any kind of display capture to work? I might have to switch the GPU to a different one. And there it is. I actually have a picture. I cannot believe that. That board is actually turned on. I will have to get into Windows. I tried a different GPU and now it's posting. CPU is at 84 degrees. That is very bad. I need to put a proper cooler onto here. And I will have to try to boot this into Windows and see. Because I expect that all of the features of the PCH are not going to be working then. So that we don't have Ethernet and some of the USB won't work. And also the internal integrated graphics won't work. But let me get a cooler onto here and then we're actually going to find out how alive this board actually is. So let me show you how this board behaves. We are stuck in a boot loop. You can see the board is now rebooting. Now we have a boot screen. And now we are on logo. And as you can see, there's nothing happening. 4.6 amps and we're stuck. And the board is going to be resetting by itself. You can see that by the LEDs coming up, by the Q-flash LEDs. Yeah, there you can see it, 2 amps, and now it's restarting. If I now hit delete and F2 to get into the actual BIOS. We are in the BIOS now. I know the view is gobbled up because the capture doesn't work. But you can see I am in a boot manager currently. Or I'm picking out the boot manager of my SSD. And as soon as I hit that, the board freezes up. I cannot move anymore. We have 4.7 amps basically stuck. And it's going to be resetting by itself. And now with reset, we have lower amps. And there was 5 amps in between. It's restarting, as you can see, giving out a picture. And now again, we are on logo and without any boot up. And we have seen almost exactly this before on another AM5 board. I think it was an MSI board, I'm not too sure. Or it was an X670. Yeah, it was an X670E board or something like that, because it had 2 PCHs on the left and on the right one. And one of them was damaged. Only when heating up I was able to get a boot. In this case, I tried to heat it up. I cannot get a boot out of this. I've tried also a different boot medium. And what I also tried is going onto the load optimized defaults and then trying to boot via that. But that also does not get us anywhere. So the board is in a brain dead state, I would call it. It does boot, but the PCH needs replacement. The PCH is dead. And yeah, some of the USB doesn't work, and Ethernet probably won't work on this. We cannot get boot out of here. I could try different slots for the M.2, but I don't think that that is going to be any different. Like, I think the main slot is going to have the highest probability of actually booting, because that is, I think, connected to the CPU directly, and the others are through the PCH. So that makes it even more unlikely for them to be able to boot. But I will be testing that. But I think this board is sadly just done for. I have tried to boot over USB into a operating system and an install medium, but that also doesn't get us anywhere. So yeah, on the 3.3 volt line, it sadly killed 2 of those switches for the PCIe and also killed the PCH on its way. But very interestingly, the AM5 platform can boot basically without a PCH into the BIOS, but then gets stuck upon entering Windows. There might be some things that you can disable and it doesn't check that anymore and then goes into Windows, but you would then have to use like some PCIe for additional USB. You will have to use an Ethernet adapter and so on and so forth. There's so many things just wrong with that. And what I would say is just this needs a different PCH. That is all that can save this thing. I still learned a lot though, because I didn't think that the board can actually boot up as far as it did now with a dead PCH. Because injecting, like from the beginning on, when I saw the resistance on 3.3 volts, I knew that the PCH was dead. Like, that is always a dead giveaway. And also, seeing, also then when we injected voltage, we saw the PCH getting hot. Like, it was inevitable. It was obvious that the PCH is dead. But I didn't think that the platform can go that far without it. And I had very little bit of hope sparked in me that it can actually do something. But yeah, in this case, it sadly does not even go into Windows anymore. I guess on the X670 it worked because one of the PCHs was fine, and heating the other one up somehow got us into Windows. But on this one, there's just no shot of doing that. Like, I've tried heating it up. I will be trying again to heat it up to at least see if I can get a single time into Windows to see this thing boot. But yeah, it's sad, but this is sadly how it goes. And maybe even with the preheater, I might be able to replace this PCH, but there's just no way of getting a good PCH somewhere. Like, I would have to take the PCH off of a board and then transplant it in order to get a functioning PCH. And yeah, I don't have a stencil also for this. So if I could get a hold of an actual working PCH for B650, I could actually try to take this off, because the B650 chipset is very small. Like, that chipset is very, very small. And with the preheater I have, I might even have a chance of replacing that. And yeah, but currently I have no source of getting good PCHs for AM5. So yeah, that would be the problem that I have. So if I find a source, I will be willing to try a actual PCH replacement on this with the preheater and the tools I have. But as of now, this is the end of this repair, sadly. And yeah, we cannot go any further with this. So, I hope you enjoyed the video. I hope you learned something. This was Mainboard Medic. All of my tools are linked in the video description as always. Hope you enjoyed that. Thank you very much and goodbye.